The broadcast is now starting. All attendees are in listen-only mode.
Good morning or good afternoon or evening if you're in Central Europe or perhaps the Middle East. I'm Millicent Pitts with Ocean Exchange. I want to welcome you to the second in a series about the blue economy that we're doing with the National Office of the Marine Technology Society. And I want to thank them for collaborating with us, and it's been great so far. This whole series is about the blue economy. This particular one is about mobile power generation and energy, or energy harvesting, as I like to call it. I do want to recognize Ocean Exchange sponsors, and you see them here, and you can see more at oceanexchange.org. Next slide, please. Ocean Exchange is a nonprofit, and we are very happy to say we're celebrating our 10th anniversary this year. And we're going to have our live event in Fort Lauderdale, October 24th through 26th. We'll be opening our call for solutions, I think as early as next week, actually. We award two $100,000 non-dilutive prizes, and that's free money to startups. We also have a collegiate award. You see here at $10,000, but we expect to be announcing that that purse will be increased in 2021, so stay tuned for that. Our mission is to help advance the adoption of innovative solutions from startups that support healthy oceans, anything about oceans. We're agnostic about the form of solution. Resilient and healthy coastal systems, because we believe you really cannot separate what happens in the near coastal areas to the big bodies of water. We also have some particular focus on the decarbonization of shipping because of our largest sponsor, Wallenius Wilhelmsen. You see some numbers here about our 10 years. Please stay tuned to hear more about our event this year and our call for solutions. Dane Dunstan, who is the MC and the moderator at our live event, has graciously accepted our offer to be the moderator of these webcasts. And you're going to hear from Dane in a minute, but now I'm going to turn it over to the Marine Technology Society. Next slide.
Great, thank you, Millie. Hello, I'm Stanka Willis, President of the Marine Technology Society, and we are so excited to be teaming up with the Ocean Exchange on this Blue Economy webinar series. So MTS has 2,000 members in 20 countries and was established to make real contributions in fostering progress in the marine science and technology for the benefit of mankind. We connect to our members through professional committees and our sections, which are both geographic, also thematic. We have a student section and our newest, the Early Career Ocean Professionals. And through our events, which are both in person, like our Oceans this year, which will be held as a hybrid event in San Diego in September, Offshore Technology Conference, which will be a hybrid event in August, Oceans in Action down in Mississippi, also in early September, and of course now virtually through webinars like this one. We're a catalyst. We piloted with SUT, the Chartered Marine Technologist Certification, and we're going to roll that program out this summer, so stay tuned. We communicate on the importance of marine technology through our journal, our monthly newsletter Currents, and through social media. So let me just turn a minute to today's topic. There's a recent paper from the high-level panel on the sustainable ocean economy. The title of that paper, Ocean Solutions That Benefit People, Nature, and the Economy, has the following statement regarding ocean-based renewable energy, and I quote, "There appear to be no relevant physical limits to ocean-based production of renewable energies," unquote. The paper, however, focuses almost entirely on wind power to generate energy. The report describes other types of ocean-based energy, such as tidal, thermal, and salinity gradient as, and I quote, "technical potential uncertain," unquote. So I'm looking forward today to looking at one of those areas, specifically thermal, to explore its technical potential. So let me throw this to Dane, our moderator, so we can get going on this fabulous panel lineup. Dane, over to you.
Thanks, Zinka. Hi, everybody. Dane Dunstan. I am with Reservoir LLC, which is a consulting company that works a lot with companies. A lot of our clients are in the sustainable energy world. One of our clients who we've been working with a lot the last couple of years is the Port of Los Angeles. And it's not always fun to have a client who's sort of front and center in the news week after week. But everything that's been happening in logistics and ocean transportation and ports is really interesting. And what's going to come out of that is a tremendous amount of growth moving forward. With our partners at Braid Theory and Carpenter, we spent a lot of time last quarter looking at how the Port of Los Angeles could get their truck drayage fleet all to be all electric. Their goal right now under the state of California rules is that they will be all zero emissions by 2035. Our job was to look at what it would take to get there faster. And so we set a goal of 2028, which is when the Los Angeles Olympics are coming up. I said, how would you work that? Really fascinating project to look at, because you've got to take a lot of factors into effect. What moves a market? What would make the truck drivers or the trucking companies go out and reinvest in new technology? What would make the technology viable? How do you get the infrastructure for charging? I want you to imagine 15,000 trucks coming in at the end of the day and parking and plugging into electricity to charge for 2 or 3 hours. What size of a parking lot would you have to have? It would be bigger than the parking lot at Los Angeles International Airport. How much power would that drain out of the rest of the city all at that time? So how do you organize that and make it work? Just a tremendously interesting project to work on. We are coming out of a period in the global economy when there's been a lot of movement and a lot of really sincere thinking that government ought to get out of the way of business and let business solve problems in a market economy. And in a lot of ways, that's great, that's worked fine. But when you're trying to do things that really change and really involve infrastructure, you just can't do that. There's no one way to do that. Everything that's happened in the last 20 years with the digital economy was created by a public-private partnership that created the internet. The military was part of it, the government was part of it, universities were part of it, and private companies were part of it. And because we worked together, public and private, to bring this whole internet thing together, now we have a whole economy based on all of this digital thing that's changing our world. How do we do that with oceans? How do we do that with green economy and blue economy and sustainability? It's really, really difficult. If you look at zero emissions vehicles, there are all sorts of competing technologies that are trying to get laws passed to favor their technology. What's best overall for the drivers? What's best for the communities? What's best for everybody? Tough question. So that's what we've spent a lot of time working on. What we're going to look at today is how we use those technological, those public-private partnerships to solve some really interesting technological problems that basically aren't yet attractive to business. They're just simply too esoteric or too, I'll say, deep, because we're talking about going really deep into studies in the ocean. It's going to take the same kind of things that we see with going to the International Space Station, with SpaceX now being the first private company to run the rocket going up there, and in the future going to Mars with the Mars platform that we're seeing up there. So what I want to do is introduce two real experts in public-private partnership, Carrie Schmaus and Robert Cavagnaro. And Carrie and Robert, I'll let the two of you introduce yourselves.
Thanks, Dane. Hi, everyone. My name is Carrie Schmaus. I'm a Marine Energy Technology Manager at the Water Power Technologies Office, which is part of the Department of Energy. I'm also involved in some young professional activities in the International Electrotechnical Commission, or the IEC, and I joined the federal government starting out as a Sea Grant Knaus Fellow about 3 years ago now. So really a pleasure to be here with you all. Rob, over to you.
Thanks, Carrie. My name is Rob Cavagnaro. I'm a mechanical engineer and team lead, so flight manager at the Pacific Northwest National Laboratory in Sequim, Washington. So my main research focuses on marine energy and the blue economy. So how do we use sources of energy from the ocean, including waves, tides, and gradients, to power applications that are at sea or for resilient coastal communities. And my background is mostly in turbine and wave energy converter development and testing, and I've recently been getting more into maritime robotics. And I work very closely with Carrie and others at the Department of Energy.
All right, thanks. Well, welcome everyone. Today we'll be talking about marine energy, in particular how it may power ocean observing. So we can dive right in. We'll go to the next slide, please. Today we'll start by talking about what the Water Power Technologies Office is. I'll quickly discuss how we support the development of marine energy, and then I'll pass it off to Rob to talk through some of our efforts in establishing customer needs through end user engagement, and then he'll speak briefly to how we determine some high value use cases. And then finally, I'll wrap up with a quick note on the Ocean Observing Prize. Next slide, please. So starting with what is the Water Power Technologies Office? We're an office at the Department of Energy, and we enable the development of marine energy systems by supporting research efforts in both grid scale and non-grid scale devices. We look at devices that convert the energy from ocean's waves, tides, currents, and gradients, so that includes salinity and thermal, into useful energy. And today we'll be focusing exclusively on the portfolio of non-grid activities, which we call the Powering the Blue Economy Initiative. You can learn more about this initiative if you take a look at our report. You can see the title of it there, as well as the cover. You can just find that online. But what this body of work does is to develop marine energy to be used for a variety of end uses. These include things like aquaculture and desalination, and also includes ocean observing, which is what we're going to focus on today. For the purposes of talking about marine energy and ocean observing, I've included how we define a marine energy device. So you can see there on the right that definition, that these devices must receive a portion of their energy needs from marine energy, but we do allow other renewable energy technologies to be included, so long as marine energy plays a role in powering, propelling, or otherwise providing useful energy to the overall ocean observing system. With that introduction to our office, I'll pass the mic back to Rob to take you through some of our research.
Thanks, Carrie. So the part of the portfolio that my colleagues and I at PNNL and also at the National Renewable Energy Lab work on is mapping a research and development strategy addressing science and technology challenges related to powering the blue economy, and then filling identified knowledge gaps and barriers through foundational research and development. So our research process starts with exploring potential application areas, of which ocean observing is one, and then really trying to focus and understand end user needs as a way of gaining knowledge in the space. Then we're trying to overcome fundamental engineering challenges that are identified through looking at functional requirements of these end use systems. Then we map and analyze the results once we conduct our research, and then we use those results to go back to our R&D strategy and again set our research priorities. And then we'll eventually go back to the top and start this process again with a different market, so maybe something like aquaculture. Next slide, please. So much of our research, though, over the past couple of years has really focused on the ocean observing market and end use application, as it's really seen as having a really high value proposition and near-term opportunity for benefiting from integration with marine renewable energy. And it includes mobile platforms like autonomous underwater vehicles. So we conducted a survey and series of interviews that targeted a really wide swath of the ocean observing community, and we got feedback from over 60 experts in the area. So we asked them about how far from shore they work and at which ocean depths, along with how much power they currently use compared to how much they'd want to have access to. So what I'm showing in these two plots is that most end users have access to and use power in the range of watts, and this is true at all distances from shore and all depths of deployment. But what we find is that when we ask them how much power they would like to have access to, most say that they'd prefer to have power, more power than they have access to. So many still would just need watts, but a lot say that they could use power in the kilowatts range or more than a kilowatt. Next slide, please. We also asked people about what they would do with more power, or what would be enabled with access to more energy, And there were some common responses about themes and uses. So a lot of these were cross-cutting and a few were specific applications. But in general, a lot of people were talking about wanting to have longer deployments for their systems. They wanted to have higher sampling rates, and they wanted access to higher power sensors, so things that you couldn't do without access to more energy. And some specific applications that were brought up, a lot of people talked about underwater recharging for autonomous vehicles. Some people talked about expanding high-frequency radar networks and working with swarms of vehicles. Next slide, please. So based on these responses, we formulated 5 ocean observing use cases that are really trying to be representative of opportunities that are potentially high value proposition. So we picked specific observing systems and locations and analyzed all the available renewable resources. So not just wave, tidal, and thermal, but also we took a look at wind and solar as competing resources. So the 5 use cases, and these include a mix of mobile and stationary platforms, are high latitude coastal weather buoys, drifting profiling floats like those used in the Argo program, high frequency radar installations, tsunami detection and alert stations. These are really good representative systems for deep water, underwater observing systems. And then the largest use case that we looked at was autonomous underwater vehicle charging. And further exploration of this one really led to the development of the first iteration of the Ocean Observing Prize. So I'll pass it back over to Carrie to talk about the prize.
Thanks, Rob. Yeah, that was a huge body of work, and we really came up with some interesting conclusions from that. And one of these, like Rob mentioned, led us to the first iteration of the Ocean Observing Prize. So I'll tell you a little bit about that now. The Ocean Observing Prize is a challenge to pair marine energy with ocean observing devices broadly. It's a $3 million prize in partnership with the IUCE office, which is the Integrated Ocean Observing System at NOAA. And the overall goal is to enable the next generation of ocean observing. And you can see the diagram there that the prize has 2 competitions. So we started with Discover, which is an ideation contest, and Develop, which is a prototyping and test contest. And so I'll tell you a little bit about where we are right now. On the next slide, you can see that the 2020-2021 Ocean Observing Prize is actually focused on self-charging AUVs for hurricane monitoring. And so you can see the diagram there. It has 3 contests: design, build, and splash, which is an open water test. And we right now have concluded the design contest and are really excited to announce the winners of this contest in just a couple weeks, somewhere in mid-April. And so I bring this up because I wanted to provide an update on where we are with the prize, but also note that while we're not currently accepting new applications for this iteration of the prize, we definitely anticipate running another prize in the future that's focused on a completely different marine energy powered ocean observing device. So if this is an area that you're interested in and you think you may want to participate in the future, please stay tuned. We do anticipate releasing another iteration of the Ocean Observing Prize in the future. With that, we'll wrap it up and say thank you for your attention, and we'll turn it back over to you, Dane. Thank you.
Thanks, guys. And we'll be back to you. Stay around because we're going to have some questions with our next speaker. We have the next slide, please. Yi Chao is the founder and CEO of SeaTrek. They do energy harvesting for ocean drones in San Diego, doing some really, really fascinating work. Founded in 2016 and focused on how can we support the industries or the researchers who are trying to get information about what's happening in the ocean. It's a sort of big invisible thing. We know less about the ocean than we know about the Milky Way and most of the observable universe. How do we learn more, and how do we get the power to do that and make that happen? So Yi Chao, let me turn that over to you, and then we'll be back with some questions. By the way, if you have questions, please put them in the tab marked questions, not in the chat. I'm tracking what's in the questions, and we'll try to get all of your questions answered as we can. Let me say something else about that. If we get some really technical questions, it's a very technical topic. If they're very technical, we'll hold those for a afterwards session, and anybody who's interested in the technical side can stay around and we'll look at those. So Yi Chao, off to you.
Great, thank you, Dane. Thanks to Ocean Exchange, thanks to MTS for providing this opportunity. Just a few words about my background. I got my PhD in oceanography went through my traditional oceanographic careers, did a postdocs, and then find my first job in the national lab. Worked for NASA Jet Propulsion Lab for 20 plus years, developing computer models, assimilating all kind of observing data into forecasting models, try to do operational oceanography, help launch the first satellite to measure salinity from space. And in the process, I developed this technology is too cool to refuse not to do the commercialization. So I left JPL 5 years ago. I started the C-Track. So I'm happy to share some of my excitement and experience of this really interesting journey the last 5 years to talk about how to use this infinite thermal energy to power float and gliders, and then hopefully AUVs in the future. Next slide. So over the last decade or so, we have seen a dramatic increase of ocean data sets, and then primarily thanks to those autonomous vehicles from surface drifters, profiling floats, underwater gliders, all the way to autonomous underwater vehicles. And we're going to see this trend continue, hopefully another 10x or 100x increase in the coming decades, which is what we really need in order to measure the ocean, to understand the ocean, so we can be able to predict the ocean similar to our atmospheric colleagues to do the routine weather prediction. So that information can be used by individuals to make their decisions and then setting policies. So that's really the exciting period to see this revolution of autonomous systems. Next slide, please. So there's a different type of underwater vehicles, and then Carrie showed nicely one of the 5 use cases of profiling floats. I'm going to dive in a little bit more, and then hopefully to touch on the underwater gliders and AUVs in the past as well. As Rob mentioned, power supply for this underwater autonomous system is the critical bottleneck for operations. Most of these underwater vehicles powered by batteries, and the battery runs out, and someone had to go there to pick it up or leave behind to replace the new ones. So either way is costly, it's not sustainable. So we are providing this innovative solution, hopefully to power them, to take advantage of the renewable energy available in the ocean, so we can power these systems continuously and with more sensors, and then hopefully to deliver more data to the community. Next slide. So the energy harvesting technology is not new. Henry Stollmore proposed this almost 30 years ago to use this ocean thermal energy associated with the temperature difference, and then to power our autonomous systems. Oceans is warm at the surface, cold at depths, and that's essentially have a thermal energy available for our use. Doug Webb has been working the first decade in the 90s and then 2000 to use this thermal energy to convert into a volume expansion, and through a phase change material melting from solid state to liquid state, to drive the buoyancy of the floats and gliders to move up and down. When we got involved in about 10 years ago, we thought it would be really cool to complete the entire energy harvesting process, go one step beyond the buoyancy engine, is to generate electricity so that we can store the electricity for future use. So essentially every time this vehicle coming to the surface and experience warm water, this solid wax-like materials are being melted into a liquid, and then give you about 10% volume expansion. The picture on the right show you those blue materials being melted, expanding in volume, and then essentially they create a pressure through a flexible tube in the center, and then you can squeeze out this hydraulic oil and then spin the motor, generate electricity. It's extremely straightforward concept, and then we patented this 2011, 2014. And that's the time I thought the technology is ready to commercialize. So I started the company in 2016, and then start this exciting journey to develop a commercial product for the community. Next slide. So up to this point, over the last few years, we have developed this commercial system we call the solid to liquid 1,000-meter systems. It's a portable energy harvesting system attached to a profiling float. In this case, it's a Navis float. Essentially, with two of these SL1 energy harvesting modules, we are able to generate essentially the entire energy required for driving the floats and then collecting the sensor data and then doing the satellite communication. So essentially, we remove the energy as the bottleneck of the entire operation. Carrie mentioned this ocean observing prize, and our entry is one of these 11 Discovery First Phase Prize winners. We are developing similar modular system for underwater gliders. Picture on the right show you a drawing for the Slocan glider designs. Essentially, almost a backpack attached to the glider, provide energy to increase the endurance and power more sensors and be sustainable, environmentally reduce the replacement of battery operation. Next slide. So one of the use case we are developing now is to try to find out how to power more sensors. Now with infinite energy available in the ocean, we can not only support the physical sensor like the temperature, conductivity, CTDs, but also biogeochemical sensors. This is one of the new application we've been proposing to power a echo sounder so that we can use the float at the park at 1,000 meters to measure the seafloor. And Dane mentioned earlier, we know more about surface of the moon and Mars and our seafloor. And then picture on the left show you 90% of the seafloor in the southern hemisphere remain unmapped. So that's the gap we hope to fill with a fleet of this kind of profiling float equipped with the echo sounder. Next slide, please. We are continuing our R&D activities to develop underwater charging stations. That's another use case highlighted in the Carrie's case. This is essentially explore the utility of the underwater thermal energy to provide underwater charging capability to increase endurance of the AUV. And this is the second prize we win during the first discovery phase of this ocean observing prize as well. Next slide, please. So if I'm not able to answer all your questions, here in my contact information. Thank you for the opportunity.
Well, thank you, Xiao. And Carrie and Robert, I know you've got some questions for Dr. Xiao. Can you kick off? Then I've got some questions from the audience.
Yeah, absolutely. Thank you, Dr. Xiao. The first question that we have for you is, in your opinion, what is the role of government in funding innovation?
That's a great question. The government play a critical role in funding ocean technology startup and the industry, particularly in the early stages, and then limited availability of the private capital. Ocean startup is very different from consumer product startup or software companies. You can triple your user every quarter. Ocean startup have much longer time to bring the technology to market, require much more resources, as you know how difficult and challenging to test any equipment in the water. And then traditionally, our market is much smaller compared to the typical Silicon Valley business model. So in that case, government play an extremely important role, fill the gap of the early phase of R&D development. For us, we developed the technology at the national lab with the government funding. So essentially, by the time we spin up the company from Caltech, we already saved a couple $1 million many years ahead. So in that case, it's critical, the government partnership in the early stage funding private companies.
Awesome. So next question we have for you is, how did you engage with potential customers and end users when you were developing your technology?
Great question. The customer, of course, drive the design of the engineering. We want to develop a solution, meet the customer's needs, solving unmet needs. two type of different customer interactions. So we have been doing in the past many years. The first type is try to make incremental improvement for the technology, essentially from 1 to 100. So in that case, you can do your survey, talk to as many customers as you want, and then to collect the requirements and then drive your design. The second one is a little bit more challenging because sometimes we bring a new technology, it doesn't exist in the marketplace. In that case, survey essentially doesn't work as well because customers don't really know what's technology available. In that case, it's really require a much closer interaction between the developers and the customers. And then through this multi-time iteration, you can develop the concept and then eventually deliver the product to meet their needs.
Yeah, certainly an important relationship when developing an early stage technology. Thank you for that. The last question we have, and then Dane, we'll turn it back to you to get some audience questions, is what is the anticipated market size for your device?
Well, if you read the news, blue economy is rapidly increasing, and then you can debate what's the specific numbers of the market size, but will be $1 trillion is the T, and then but as a small startup company, the business textbook taught us to start a relatively small market, so we don't have a lot of competition. So the market we started is focused more on the research and then defense applications, so profiling float, underwater gliders, and then that's probably have a market size of tens of millions, maybe less than between $50 to $100 million. And that's hopefully will get us to maturity of the product and then increase our capability to do the commercialization. Now we have a commercial product, we are ready to attack the next market, which would be much bigger, hopefully with the B.
So let me jump in on a couple of questions from the audience. And let me start with a couple for you, Dr. Chow. Dara Farrell asked, do the SLG gliders, are they equipped with acoustic centers, hydrophones?
We are providing the energy modules is up to the customer. We provide power. We try to understand the power requirement for these extra sensors. And then that can be attached to the gliders. We partner with the glider operators. We partner with the glider companies. So potentially that can provide extra energy to power those sensors.
Okay, it just depends on the use case for them then.
Mm-hmm.
Okay, here's a question from Jacob Gladfelder, and it's about the PacWave South test site. Not sure who that's aimed at. Who could talk to that?
Rob,
I can do my best. I'm not an expert at PacWave, okay, but.
Here's the question, just an update on the progress of it and how sites like these enable collaboration between the DOE and private industry.
Sure, yeah. Without being, deeply involved in that project, I'll give you sort of my understanding where things are and kind of where it's headed. But the thing that's really exciting about PacWave is that it provides an open ocean test site in a highly energetic area off the coast of Oregon. It's going to be grid connected, so it's a really exciting opportunity for folks that are looking towards the grid market to test out some of their devices in a real world scenario, and it's pre-permitted, which I know is also a major challenge when we're thinking about putting things out in the ocean. So that's a major benefit. In terms of enabling collaboration, I think the opportunities are really endless once we have an area for devices to be tested. I think we've spoken a little bit about how important it is to have that end user collaboration when we're developing early stage technologies here today. And so I think having an area like PacWave that's pre-permitted and available for folks to test really enables people to get together with end users and come up with a solution that can then be tested at PacWave. I would encourage folks to visit the website. That will definitely have a more up-to-date status report than I'm able to provide here. So sorry for not being able to provide a deeper insight into what exactly is going on in PacWave at the moment, but all that information is online.
All right. Hey, interesting question from Omnia Ibrahim, and I don't know if this is too technical, but let's try it. He asks, is there a programming language that's used in the programming of gliders in the case of very high temperature? Does it need a specific language, or can any language be used? Or is that too technical?
I think I needed some clarification for the question.
Okay. I wish I could give you some. I would be thrilled if I could do that. John Kemp asked, what modifications were required to the float in order to use the C-Trek generators?
There's a minimum modification. We work with a company like Seabird and NKE, and then essentially we plug in our cable into the floats that provide actual power. If we're able to harvest energy in the environment, there is a temperature difference. The float is smart enough to figure out actual energy being generated. They will use our energy first. So essentially the battery within the float remain unused. So ideally, if we provide 100% continuously, the battery will remain as a backup system for the float. So minimum modification required.
Here's a question from Heike Schmitz. Do you think the C-Trek technology could also be used for recharging surface autonomous vehicles that already use wave energy for movement, but are in need of more energy?
Potentially we can, but we don't consider us as competing with the surface source of renewables. And then they are more efficient on the solar panels, wave and winds than thermal. Thermal energy conversion have a theoretical limit how much we can convert this secondary heat stored in the ocean. So we see ourselves as a complementary source for underwater with no surface expression for certain customers, less logistic cost to install a system without surface expression.
Great. And speaking about power capacity, Aryan Anand asks, how much power do you think the future product, the infinite recharging station, would be able to produce, say, in 2023 and then again maybe in 2030?
So far we have customized our energy output to the platform we try to power. For the float, typically take about 10, 20 kilojoules per dive. Gliders, maybe 20 to 30 kilojoules. For underwater charging station with our existing technology, we hope to generate on the order of 1 kilowatt hours per day, so allow the small AUVs to come back to charge. We are developing liquid to gas phase change energy harvesting. Hopefully that get into 10, 20, 30 kilowatt hours per day for the larger AUVs.
Okay. Robert, question for you. Are the results of the user surveys you mentioned, are those available publicly?
Yeah, they are. So we have a publication from the MTS IEEE Oceans Conference in 2019. It's available through IEEE Explorer. And then we have additional information on those 5 use cases publicly accessible through OSTI. Search for Powering the Blue Economy Use Case Report, and that'll provide some more details on those use cases.
Okay. I always rely on Kathy Sakis from Ocean Exchange Board to get an interesting question. This is a good one. What's the minimum temperature range in which the phase change technology can operate for the generator?
Good question. We just need a few degrees above and below the phase change temperature, which can be adjusted, depends on the geographic area and the material we try to provide. Normally from 5 to 10 degrees C, or maybe 15, 18 degrees Fahrenheit.
And what modifications were required to the float? Did I ask this one in order to use the C-Trek generators?
Yeah, basically we are serving as a reseller for the float, so customer can order the end-to-end system from us. So we go ahead and you tell us which float platform you prefer. We go acquire those floats, and then essentially we do the integration and testing. We deliver the end-to-end system ready to be deployed in the ocean.
Well, great, thanks. That does the audience questions. I'm going to hand back to Millie.
Great, Alice, if you can, here we go, roll the slides. I want to thank Dane Dunstan. I'm going to brag on him. He does all of this pro bono for us. He's just terrific. He has his own leadership consulting business. He's written books. He's written stand-up comedy. There's nothing that he can't do, and he's a dear, great friend to us now. Thanks, Dane. Next slide.
Thanks, Millie.
May 5th, we have a topic on aquaculture. Watch for all the publicity and the link to, to get in that system. And we welcome everyone again, May 5th. That will also be 11 a.m. Eastern, 5 p.m. Central European Time, and 8 a.m. Pacific Daylight Time. You see the various links here. I couldn't miss an opportunity to say again, October 24th through 26th in Fort Lauderdale is our event. Watch for news about that. You see our link, the MTS Society link as well. Next slide. Again, we couldn't do this without our partners, the MTS, our sponsors. Please send us feedback. We've made adjustments to these webcasts over the last year based on your feedback, and we welcome that. And thank you all very much. If Dane, are there any remaining technical questions in the Q&A? We ask people.
No,
did we cover everything?
We got all the questions.
Great.
We did.
So thanks to everyone. We have people behind the scenes that make this work. Alice Philman, Monica Ostrander, and Christina Norman. Those last two names are MTS staff members. Alice is with Ocean Exchange. Prior webcasts are in our library and in the MTS library as well. You can see these links. You can also, I'm sure, find it on our respective websites. Thank you all very much. See you next month.
Thank you.
Thanks, everybody.
Thank you.
So much.
Thank you.